Okay, so this next section in quadratics is the vertex form of a quadratic equation. So the vertex form is an easier way. Instead of the way we've been doing it is we've had a trinomial and we've had to calculate our axis of symmetry and then go and calculate our vertex. Go and calculate our y once we have our x, and then have our vertex, find our vertex that way. The thing with the vertex form, it's you can automatically see the vertex already, so it's a little bit less math that you have. It's way less math that you have to do. So the vertex form of a quadratic equation is in the form y equals a times x minus h squared plus k. H comma k, which are two new variables that we have introduced, are actually the vertex spots. And then your axis of symmetry is going to be h, because remember your axis of symmetry is the x line. It's a little bit confusing right here, but let's look at some examples to get it a little better. So if you notice, since your equation already has a negative h in here, then if it's subtraction inside, then your h is positive. If it has a positive addition inside of the parentheses, then your h is going to be negative. So looking at some examples, number 1, I want you to give the axis of symmetry and the vertex of each equation. So your vertex is going to be h comma k that you get from your equation, h and k. So I like to write out what your h is equal to. So remember what I said, if this is supposed to be minus. Put it back into this form. To do that, all you have to do is say y equals x minus a negative 4 squared minus 2. Now you can see that it is x minus, and then here is your h right there. Here is your h, and here is your k. So then your h is a negative 4, and your k is a negative 2. Now your axis of symmetry is going to be the line x equals h. H is negative 4. Your vertex is h comma k, which in this case will be negative 4 comma negative 2. And bam, you can quickly find your vertex form in this setup. That's what this vertex form is. You can quickly find your vertex, you can quickly find your axis of symmetry. It requires a whole lot less math. There we go. Okay, let's look at number 3. No. Yes. 3 and then 4, and then we'll move on. So again, h equals, k equals. Since there's already a subtraction in here, then we are in the correct form. So then your h is going to be the 5, and your k will be the minus 4. So your k is always the value on the outside. If there's no value on the outside, like, I guess we do need to do all 4 of these. We'll get to number 2 in a second. If there's no value on the outside, then it's just 0. Your k would be 0. But in this case, our h is 5, and our k is negative 4. So then our axis of symmetry, remember, is x equals h. So x equals 5. Your vertex is in the form h comma k, which h is 5 and k is negative 4. Okay. Number 2, we are in subtraction, so that's good. So then this value and then this value is going to be our h and our k. Your h is 3. Your k, if you circle a big blank box, then that's just 0. So then your axis of symmetry is x equals 3. And your vertex would be 3 comma 0. Give this a second to dry. Alright. And then doing number 4. Again, h and k. You can set this up so it'll look like the standard form, the vertex form, so it would be y equals -2 times, since it's x by itself, then it's given that that would be x minus 0 squared plus 3. So we have minus, minus, okay, that's great. We have a 0, and we have a positive 3. So then your h would be 0, and your k would be a positive 3. So your axis of symmetry is the line x equals 0, and your vertex is at 0, 3. Alright, moving on to graphing from the vertex form. So graph each equation using a table of values. Identify the axis of symmetry, vertex, domain, and range. So we're going to identify those 4 things right here. Then we're going to fill out this table of values about the same way. Vertex will go in the middle, fill it out on the left and on the right, except we'll be plugging numbers into this vertex form instead of our standard form like before, and then we'll be plotting our dots and connecting them with a nice little parabola. So looking at number 5, we have y equals negative, in open parentheses, x plus 2, close parentheses, squared, plus 7. Alright, so your axis of symmetry, all you need to know for this is to find out your h and your k. We do not have addition, so from here, if you have addition, and your h is going to be negative, and then it would be that 2. And then your k is going to be that 7, that positive 7 up there. If that's not, and you like it looking like it does in vertex form, then you could write that negative in there. It would just be negative 2 squared plus 7. I'm going to write this in parentheses, because a negative times a negative would give you a positive. So you can unravel that positive sign and get 2 negatives. Okay, and then so remember your axis of symmetry is that h. So x equals -2. Your vertex would be -2, 7. Remember, domain on these, we'll be able to see it more in the graph. Alright, so plot your vertex in the middle, -2, 7, and then fill in the top. The numbers immediately to the left would be -3, the number immediately to the left of that would be -4. This is as if it was on a number line. The number to the right of -2 would be -1, and then the number to the right of -1 would be 0. So then plugging each of these values in for x up here, right up here would give you, if you plug -4 in for x, then you would get y equals -4 plus 2 squared plus 7. Alright, solving this one by hand, you could do the inside according to PEMDAS. Where you do multiplication and division and addition and subtraction from left to right. You have to do anything in parentheses or anything in grouping. So you'd have to do the thing in the grouping, simplify this before you can do the exponent. So this would give you a -4 plus 2 gives you a -2 squared plus 7. Notice I kept that negative out there because this negative is multiplication, which comes after doing our exponent. So then this, doing the exponent, -2 squared would give you negative, open parentheses, 4, because -2 times -2 is 4, and then plus 7. Well, a -1 times a positive 4 is going to give you a -4 plus 7, and this is going to give you a positive 3. So this one would be positive 3. And then you could do it the same way, plug in -3 in for 4, plug in -3 in for x, so instead of -4 we would see a -3 right there. Or, if you have your handy dandy calculator, we're going to do -3, you can type it out. So start typing out negative, open parentheses, we're working with -3 in for x, -3 plus 2, close parentheses, squared, plus 7. type it out exactly as it looks, hit enter, and you'll get back 6. So we'll put a 6 right here. And then I'm going to do that all over again, except I'm going to put -1 in for x. So I'm going to copy and paste that and go change my 3 to a 1. Enter. I'm going to get back 6. And then I'm going to copy and paste that again, because now instead of -1 as my x, I'm going to put 0 as my x. So I'm going to hit 0 and hit enter, and that gives you back 3. Alright, so then the graphing. Plotting this, starting at the center, plot number -4, 3 would be go to the left 4, 1, 2, 3, 4, and then up 3, 2, 3. And then -3, 6, you go to the left 3, starting at the origin again, 1, 2, 3, and then up 6. 1, 2, 3, 4, 5, 6. And then plotting -2, 7, you go to the left 2 from the origin, 1, 2, and up 7. This was up 6, and this one's going to be up 7. And then notice this next one, it goes as high as 6, which we already have one going as high as 6. So to the left 1 and over 6. Alright, then plugging 0, 3. 0 means we don't go left or right, but we do go up 3. And that'll be the same height. Right here, right here. And now, curving this. And going straight through this one, and keep it straight, 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 straight. And turn it off. And then I start back up at the vertex, and I follow the curve down. I may have missed this spot a little bit, but that's fine. And there you go. Now you can see that this is never going to end, so it's going to slowly go to the left, go all the way over to -infinity and +infinity. So that would be all real numbers. That is your domain. Your range going from bottom to top, since this is a parabola that opens down, then it's going to go down to -infinity, going from the bottom to the top, -infinity, and the highest point it's going to touch is this y value in the vertex, which is going to be 7. So we have our y, we have our 7. The y indicates all the y values we're going to touch, and all the y values are going to be less than or equal to 7, because 7 is the greatest thing we touch. Okay, and then doing this next one, we have y equals, let me fix this, y equals 3 times x minus 1 quantity squared. We are in negative, so we're good. So our h would be this one. Our k, if you circle nothing, remember that is 0. So in your axis of symmetry would be x equals 1, and then your vertex would be the coordinate points 1, 0. And then place 1 as in your x and 0 in your y in the very center. To the left of 1 we would have 0, and to the left of 0 we have -1. To the right of 1 we have 2, and to the right of 2 we have 3. Now plugging each x value in for x, each of these x values in for x to get your y. Remember, since this quadratics are a function, so for every x input you put in, you will get one y input, only one. So you will not put in an x input twice and get 2 different y values. If you do, then you probably dropped a negative sign or something, because that should not happen. Okay. So I'm going to start at 3, open parentheses, and start with -1. -1 in for x. Then we have -1, close parentheses, squared. 3 times -1 minus 1, 3. And that gives you back 12. Alright, and then I'm going to use that same exact equation, except instead of -1, I'm going to put 0 right here. So I need 0. And that gives you back 3. Okay, move this one to the left side. Okay, and then using that same exact equation again, except this time putting in 2 instead of 0. And all I'm changing about this is the x value. Where the x was, I'm putting in different numbers for x. Everything else about it stays the same. Okay, you should get 3 back. And then doing it again, except putting 3 in this time, you should get 12. Alright. So, graphing this, you can go left 1, but notice if you try to go up 12, the highest you can go is 8. So if it comes off the grid, that's fine, just start with the next one. So we can graph 0, we couldn't graph negative 112, but we can graph 0, 3. So 0 means we stay put and just go, and the 3 means we just go up 3, 2, 3. Then graphing 1, 0, go over 1. 0 in the y space means we do not go up or down, we stay the same. And then 2, 3, so go back, go over 2, and then up 3. And then notice again we are challenged with that 12 as a y value, but it's okay. You really do need at least 3 dots to graph a quadratic in the correct spots. Alright, so giving it the parabola look right here and following it up. And then going back to my vertex and following that up. There we go. There's a parabola. Again, it is going to be another all real numbers because of the never-ending lines on each side. And then this range will be y on the left side again. And then if you go from the bottom to the top, you notice you don't touch anything. It doesn't touch until this very line where y is equal to 0. And then it's going to go off to positive infinity because these lines will not stop. So putting a 0 right here, the smallest number it touches is 0, but it touches everything else greater than, it touches from 0 and anything greater than 0. So that means the smallest number it's going to touch, and that would be your range. Y stands for your graph, so your graph is going to touch all numbers greater than or equal to 0. Okay, and that's how you graph using your vertex form. Now then, transformations from the parent function. The most simplistic quadratic equation is y equals x squared. It has a vertex of 0, 0. It's the most simplistic one because your a equals 1, your b equals 0, and your c equals 0. And that's as simple as you can get your quadratic equation because you do have to have that x squared. So x squared, so this y equals x squared function is actually known as the parent function. It's known as a parent function because since this is the most simplistic, they took the original one, the parent function, and then adding on other numbers will change it depending on where it goes. So it'll change it to move left from its position, right, up, down. So then a transformation is the change to the size or position of a figure. To the size or position of a figure. Just like how a transformation for somebody might be them cutting their hair, changing their hairstyle, changing the way they dress. It's changing from the original function. So we're going to be graphing each function and we're going to describe how it compares to the parent function shown on the graph. The way we do that is we're going to be doing transformations. So then, since this is plus right here, that means your h value is a -2 and your k value is 0 since there's nothing on the end. So following along with that, the same way, put -2, 0 in your very center, and then to the left of -2 we have -3, and to the left of -3 we have -4. To the right of -2 we have -1. And to the right of -1 we have 0. Now then, to find all of these y values, we are going to be putting negative each of these values in for x. So we have open parentheses negative 4 plus 2 close parentheses squared. This is going to give you back form. Okay, now I'm going to replace that negative 4 with negative 3. It's going to give you back 1. Then I'm going to replace that negative 3 with negative 1, which gives you back 1. And then I'm going to replace that negative 1 with 0, which should give you back 4. Okay. The function that's already graphed is your parent function. That is what the graph of y equals x squared looks like. So then we're going to graph it, and do use a different color so you can see the difference. The function that we just found right here of y equals x plus 2 con v squared. So then starting at the origin, we're going to go left 4 and up 4. And place our dot. Then we're going to go back to the origin and go left 3 and up 1. And then go back to the origin, and then we're going to go left 2 and not go up or down, so 0. And then placing negative 1, 1, and 0, 4. Remember, these next two dots should be equal. So drawing a nice and smooth parabola, you can see that our equation is similar to the parent function, it's just off. And the only difference we have, the one that we drew is moved 2 units to the left. So if we had moved this 2 units back, then this would be perfect. Notice that 2 units to the left goes with the negative 2 in your h. So since h was negative 2 in your vertex form, then you moved this 2 units to the left from the parent function. This is what's nice about this vertex form, as you can see what you're doing. Okay, skipping down to number 10. Alright, since we have subtraction, then we do not need to change the sign of our h. Then it is perfectly 4. And then your k would be 1. So then placing 4, 1 in the middle. To the left of 4 we have 3, and then 2, and then 5, and then 6. Finding each of these values. Alright, we have a negative sign in front, open parentheses. Instead of x, I'm going to put 2 in there, minus 4, close parentheses squared, plus 1. This is going to give you negative 3. And then doing that again, except putting a 3 in for 2, 3 instead of 2, you'll get 0. And then again, except with a 5, 0, and then again, except with a 6, negative 3. Alright, and then remember, this one should be a different one, and then immediately to the left, immediately to the right, you should get back the same y, and then 2 to the left and 2 to the right should give you back the same y. Okay, so graphing this, starting at the origin, going to the right 2, 1, 2, and then down 3. Okay, going back to the origin, going to the right 3, and not moving, up or down. And then going back to the origin, going to the right 4, and then up 1. Going back to the origin, going to the right 5, and staying at 0. Back to the origin, going to the right 6, and down 3. Okay. Now graphing this, bam. Alright, this one looks completely different from the before one. I want to note some things. The first thing to note is that our parent function was opening up, and our other function, equation that we're working with, is open down. What changes this is that negative sign in the front. Is when your a is negative, then you will have a reflection Right now it'll be a reflection, but right now we'll just call it we flipped it. We flipped it. We flipped our parent function over. Okay, so then the first thing we did was flip it. Now what you need is, did you move right or left any? And you did. You moved 1, 2, 3, 4. Your vertex moved to the right 4. And then it moved up 1. And then notice again how your vertex moving depends on your x value and your y value. So if your x value is a positive 4, then your vertex went to the right 4 from the parent function. If your y value is a positive 1, then it went up 1 from the parent function. And the reason we use the vertex is because it's the easiest one to find. So using the vertex, you can figure out how far you moved. Okay, and then doing number 11, remember if your x, there's nothing inside of your parentheses and it automatically goes to x squared, then your h is 0. And then here we have our k of -7. So placing 0, -7. Okay, then we would have -1, -2, and then 1, 2. Placing each of these in there, we have 3 times -2 squared minus 7 gave us back 5. Redoing that equation, except with a -1, do back -4. Redoing that, except we're going to have +1, gives you back -4. And then redoing that, but with +2, gives you back a +5. Okay, and then graphing this new function, well, this new equation, we're going to go to the left 2 and up 5. Go back to the origin. Then we're going to go to the left 1 and down 4. And then we're not going to move, but we're going to go down 7. And then we're going to go to the right 1 and down 4. And then to the right 2 and up 5. Okay, if you notice already, your dots that you drew on this next one, this looks a whole lot skinnier. Whoops. There we go. And you are correct, because having the number 3 out front made your graph skinnier. It's compressing it. Horizontally wise, it's compressing it. Vertically wise, it's stretching it out. So that would be the first thing to note on your transformation, is that you are stretched. And then the next thing to note is, now once you've gotten those characteristics, then what happened to your vertex? Your vertex didn't go left or right any, because your x value of your vertex is 0. But since your y value is -7, and you can see that your vertex went down 7. And those are your transformations. And then doing number 12, we have negative, so we're good. Our h is going to be a +3. Our k is going to be a -2. So placing those in the center, 2, 1, 4, 5, and then graphing them, we have -1/2, open parentheses, so instead of x I'm going to place 1, -3, make sure that's a subtraction and not a negative, -3, close parentheses squared, -2. Hit enter, this gives you back a -4. Now I want to use that exact same equation again, but I want 2 instead of 1. Okay, you'll get a -5/2 back, and you can change that into a fraction, or to a decimal, by either hitting math and then hit decimal, or you can hit 5 divided by 2. And it'll give you back 2.5. Well, negative 2.5 because we had a negative out there. And then doing this again, but with 4 instead of 2. You get a negative 5 halves again, but we already know that's negative 2.5. And then doing this again, but with 5. You'll get back a negative 4. Alright, now let's go plot. Alright, so starting at the origin, we're going to go to the right 1 and down 4. Okay, starting at the origin again, go to the right 2 and down 2. And then instead of going down to 3, we're going to go to halfway between 2 and 3. Right there. And going back to the origin, going to the right 3 and then down 2. Well, that's down 1. Down 2. And back to the origin, going to the right 4 and then down 2.5. Make sure you go 2 and then half step. And going to the right 5 and over down 4. Alright, this one you can tell since you went into the halves. You can start to see that whereas this one's a little bit slimmer, this one looks a little wider. So if you have a fraction and your A spot, you're actually going to look more compressed or wider. And then we didn't notice that this one was opening up, but since this one's opening down, we also reflected or we flipped it. And the negative sign right here is the cause of this being flipped. The 1/2 is a cause of the compressed / wider. And then looking either at your vertex to see that you went right 3 and down 2, or you could go back to your origin and then you could go 1, 2, 3. You went to the right 3 and down 2. So your vertex moved to the right spots and then down 2 spots. So when it's asking you for transformations, it's asking you how did the function that you just graphed differ from the parent function. Alright, so putting it together, H, so from what I've said out loud, let's write it down. So H is the horizontal shift, so left or right. So if you have a plus in there, you're going to shift to the left. If you have a minus in your H, you're going to shift to the right. And that has to do with right here. So if we had a minus, but our H turned out to be positive, so that's why you have to shift to the right. And then one of our previous ones, it was positive inside right here in your equation as H, but when you pulled it out, your H was actually negative, so you shift to the left. So I recommend keeping this sheet in handy when you're finding your transformation. So positive inside of here, you shift left. Negative inside right here, shift right. And then K is your vertical shift. So vertical is up and down. So if you're positive, this one goes right. So if you're positive, you shift up. If you're negative, you shift down. So if your A is negative, we called it flipped, but the correct term would be to be reflected across the x-axis. So you reflected this across your x-axis. And then if your A is a positive number greater than 1, then you have a vertical stretch. So that just means if your A is any number greater than 1, like a whole number, right here, notice that stretched your function. But if your A is any number, if the absolute value of your A is any number between 0 and 1, that is a vertical compression. As we saw here, this one was a little bit smushed more vertically, and this one was stretched out vertically. And it has to do with that number, that 8. Alright, so then writing equations. The last thing we got to talk about is if you're given a verbal or a written description of it, you need to be able to write it down. So using this right here, so transformations from the parent function y equals x squared are described below. Write an equation to represent the function. Alright, so if we're translated 2 units to the right, that means we are going to have a number in here, and everything else is, this is 1 and this is 0. So we would have y equals, well, if we're going 2 units to the right, then we need a subtraction inside of here. So that would just be x minus 2 squared. If you're being brought up 5 units up, but you're not being moved left or right any, then your h is 0, and your equation would look like equals x squared. Up, remember, is plus, so you need a plus 5. Alright, if you're translating 3 units to the left and 4 units down, that means you have an h and a k. So we will have numbers in h and k. So 3 units to the left means we're going to have a plus inside here. So we'll have y equals x plus 3 squared. 4 units down means there's going to be a minus in front of our k. Minus k. Minus 4, because we know we're going down 4. Okay, and then number 16. If you're being translated 7 units right and 4 units up, then we're going to have an h and a k again, and you'll have y equals, open parentheses, x. If you're going to the right, then you're going to have subtraction inside your parentheses, and you're going 7 units to the right, close parentheses squared, and then you're going 4 units up. So if you're going up, then that'll be plus 4. And then doing number 17, reflection over the x-axis. That automatically tells you there's no compression either. That tells you that there's going to be a negative in the front. And then you look out, we're going to be moving left or right to see if we're going to have a number inside the parentheses. Then translated 3 units down. If you're not being moved left or right, then it's just x squared. And then 3 units down, remember, is minus 3. Because the number on the outside, this little constant out here, is always what brings you up or brings you down. Okay, number 18. Again, we have a reflection over the x-axis. So we know there's going to be subtraction. There's going to be a negative sign up at the beginning. Then we're going to be translated 5 units to the right. Being translated to the right means we're going to have subtraction inside of our parentheses. So x minus 5, close, squared, and 2 units down. Down is subtraction, again, so minus 2. Alright, number 19, we're going to be vertically compressed by a factor of 1/3. So if it says vertically compressed or vertically stretched, that means you're going to have a number in front of your parentheses or in front of your x squared. In this case, we're going to have 1/3. I don't read any reflection, so we will not have a negative. It'll be a positive 1/3. I do not read anything that says left or right, so that means that we're going to just have x squared, and then 8 units up would be plus 8. And then the last one is 20. Vertically stretched by a factor of 2. That means we're going to have a 2 on the outside of our parentheses, and then reflection over the x-axis tells you a negative 2. So make sure to put that negative in front of your 2. Alright, so we did this, we're done here. And then translated to 4 units to the left. Remember, when you're being moved 4 units to the left, that means you have a plus inside of your parentheses. So it will be x plus 4 squared. It says nothing about me being moved up or down, so we're going to stay, and now it'll be just blank, or plus 0. Alright, so we went from having the equation and then figuring out where we move left to right, and now we're telling us move left, right, flip it, reflect, compress, stretch, and you are the one to give an equation. You can always just regraph it in your calculator or an online calculator as well, and you can double check it and count to make sure that you're doing okay.